Welcome. This is Geometry A, Unit 8, Lesson 10. We're talking about similar figures and area. We're entering a series of lessons on what happens to area and to surface area and to volume and to perimeter when we multiply the scale, multiply the dimensions of an object by a constant factor, by a scale factor, hence creating similar figures. I have on the screen a picture of some squares. One square, the one on the left, is 1 by 1. The next square is 2 by 2, 3 by 3, 4 by 4, 5 by 5. And we could continue the pattern on. What I'm interested in determining is the areas of each of the squares. There's a couple of ways you can find those areas. You can count the squares. The area here is 1. The area here is not 2, but 4. Area here is not 3, but 1, 2, 3, 4, 5, 6, 7, 8, 9. The area here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And this is getting old. I can hear you saying it right now. There's got to be an easier way to figure this out. Well, there's 5 rows, 5 columns. 5 by 5 makes 25. Okay, so we can just multiply. And so notice that each one of these comes from a square. This is 1 squared. This is 2 squared. This is 3 squared. This is 4 squared. This is 5 squared. That is to say, and let me write this out in very clear words so that you don't miss it. If we scale a 2D shape by a scale factor, let's say it's K, we multiply its area by K squared. Okay? That's the idea. That's the big idea of this lesson. If you multiply the scale by a scale factor, multiply all dimensions of a shape by a scale factor K, you multiply its area by K squared. That is, the scale factor gets squared or multiplied by itself. Let me show you how this is applied. Let's say we have a triangle. Okay, and I multiply the dimensions of the triangle by a scale factor. Let's say I multiply by 1.5. Okay, what this tells me is I will multiply the area by 1.5 squared. 1.5 squared. 1.5 times 1.5 is 2.25. So the area will be 2.25 times bigger than the original, which is interesting. You only increased the scale by 50%, but you increased the area much more. This has a lot of implications in physics and science. But let's go ahead and apply this to this problem here. Let's find the area. Okay, the area of this particular shape here, the length, is 1, 2, 3, 4, 5. And the height is 3. So if I find the area of this, area is 1/2 base times height. 5 times 3 is 15, times 1/2 is 7.5 square units. And I can verify that. 1, 2, 3, 4, 5, 6, 7, and about 1/2. So that does seem like a reasonable area. So what we're saying here is the area will be multiplied by 2.25 for the new area. So if I want to find the area, I can find the area without even finding the new dimensions. Multiply by 2.25. Let me clean that up here a little bit. 2.25. Okay, so 7.5 times 2.25. I don't have that in the top of my head here, so let me pull up Desmos. Oh, Desmos, here's my Desmos. Who's the best Desmos? Desmos.com. Not the Des least, but the Des most. Here we go. 7.5 times 2.25, 16.875. So the new triangle will have an area of 16.875 square units. So more than double, about double and a quarter, right, than the original. Let's verify that. Let's actually go through the steps of changing the dimensions. 5 times, let's go here. 5 times 1.5. 5, half of 5 is 2.5, so 1.5 times 5 is 7.5. So the width is going to be 7.5. 2, 4, 6, 7.5. Okay, 3 times 1.5. 1.5, half of 3 is 1.5, so 3 times 1.5, 3 and 1.5 is 4.5. So we're going to have a height of 4.5. So we're going to have, and by the way, this is, if I want to keep it truly proportional, this is 4. 1.5 times 4 is 6. So 2, 4, 6. There we go. So up 1.5, up 4.5. 2, 4.5. Okay. So the height is 4.5. Okay, and let's draw our triangle, or draw our triangle. It's a triangle. A triangle. Yeah. Triangles never get anything accomplished. They only try. They never do. They're triangles. They're not do-angles. Here we go. All right, let's check out the area. Let's see if we get the right area. So area is 1/2 base, 7.5, times height, 4.5. Okay. 1/2 base times height. 1/2 times 7.5 times 4.5. 16.875. Okay, and here's why that works. Let me see if I can demonstrate why it works a little bit. I just demonstrate what to do when you're given the dimensions. Find the area of the original shape, multiply the area by the square of the scale factor. But I do want to show you why it works. Okay. So let's say we've got a triangle. A triangle. All right. And we'll apply it specifically to triangles. We can use any formula we want here. Okay. So a triangle with a given base and a given height. Okay. Let's say the base is B and the height is H. Then the area of the triangle is 1/2 base times height. Now let's say I multiply all the dimensions by a scale factor K. So B times K, H times K. Now my new form area becomes 1/2 base times K, H times K. Rearrange a little bit. This is 1/2 BH times KK. Right? We can multiply in any order, which is the original area. Let's call this area 1 and this area 2. Okay? area 2 equals 1/2 BH, which is area 1, times KK, or K squared. Okay, so this just re-emphasizes or reinstates the idea that when you multiply dimensions of a shape by a constant, you multiply the area by the square. All right, that's it.